trigonometry. Trigonometry is the study of triangles. As the name implies, tri means three. Gono means gonometry. We are talking about geometry in this case. It means the study of three-sided shapes. And the three-sided shape we know is what we call the triangle. We have different types of triangle, but for the introductory part here, we are going to be looking at only what we call a right angle triangle. A right angle triangle is a triangle that has one of its interior angles, as 90 degrees. And that is the type of triangle we are going to be looking at today. As the name implies, tri means a shape with three angles, interior angles, and as we can see, it also has three sides. And by extension, it also has three identities, which are the sine, the cosine, and the tangent. And also three reciprocals, which we'll be looking at as we continue in our next class. So here, previously in grade 9, we were dealing with three-sided shape as well, also where we were using our Pythagoras theorem and our Pythag. The theorem says that the square of the hypotenuse will always be the sum of the square of the opposite and the adjacent. How do we figure out where is our hypotenuse, our adjacent, or the opposite? In every right angle triangle, irrespective of the shape, the first thing we do is also always to figure out the angle that is 90 degrees. The side facing that 90 degrees is always our hypotenuse. Then the other angles can swap around depending on the angle we are dealing with. The length can swap around. If we are dealing with this angle alpha, this becomes the opposite, and the other side automatically becomes the adjacent. If we call this angle theta, then the angle facing the side facing the angle theta becomes the opposite of that angle. So irrespective of the shape of the triangle, so if we have triangle XYZ and this is our theta, this becomes the opposite of theta. If this is right angled, this becomes the hypotenuse and this becomes the opposite. Automatically the other side becomes the adjacent of theta. So remember, the adjacent and the opposite can swap around, but the hypotenuse must be that length that is facing the right angle. Now, in grade 9, we were using Pythagoras theorem to solve problems when the length of the two sides are given and we are required to figure out the third length. But one of the cases where we only have one length, or maybe one length, two interior angles given, or one length, two lengths, and one interior angle given, and we are asked to figure out the interior angle or the other lengths. So by extension, it will be difficult for us to go through such problems using the Pythagoras theorem, and that is where we bring in the three identities I mentioned previously. The three identities are the sine, the cosine, and the tangent. Now we use a method we call the SOHCAHTOA to solve such problems. SOHCAHTOA is an acronym that we use to figure out this. We are the first letters of this represents the three identities, sine, cos, and tan. It means that when we have the opposite and the hypotenuse given, we can use sine. When we have the adjacent and the hypotenuse given, we can use cos. When we have the opposite and the adjacent given, we can use tan. So, for instance, if we have this as the angle involved, then whenever we are using this angle, it means that the opposite, that is the slope, the opposite and the hypotenuse is given. If we are using cosine, it means cos, and cos goes with car. Then cos of theta will be when adjacent and the hypotenuse is given. And tan of theta, in this case, tan of theta will be adjacent. Opposite over adjacent. Please note this. If we swap around these letters, it will not yield the desired result because it has to be in this form. Okay? O must come before the hypotenuse. Adjacent must come before the hypotenuse for cos, and opposite must come before the adjacent for tan. If we swap them around, we will not get the desired result. These are the methods that we can use to solve problems when a right angle triangle is involved. We can use hypotenuse if we have the length of two sides given to get the third side. But if we only have the length of one side given and an angle given, then we can employ our SOHCAHTOA. And this way we can easily solve for the lengths of a right angle triangle or for the unknown angles in a right angle triangle using Pythag and SOHCAHTOA. We will take more examples. This is just laying the foundation, but we should understand that this is what we will be using to solve problems involving right angle triangle for now. See you in the next video.